Let's Google sensor open system architecture, and we're going to click on images. Now, these systems are broken out to every branch so that they can weaponize the air molecules or clean them up. Sensors open system architecture, Sosa, for all branches of the military. Sosa, that is all of them. And then there is MOSA. That's your module open system approach, changing out the hardware to change out the software of the sensors. They are all required because that's how those sensors are being accessed to use Sosa and MOSA. And that is what you're dealing in sensors and hardware that is plug and play, drones, F-35s, or whatever.
Yeah, so if we look at the image, you can see that the DoD MOSA initiative, it has the Army, the Navy, the Air Force, and intelligence. So these are all part of the same SOSA system, the SOSA and MOSA system.
You're monitored and controlled via Sensors Open System Architecture, SOSA, and Modular Open Systems Approach, MOSA, using 6-glow pan-RF signals that are Zigbee Bluetooth enabled. Anyone with the expertise could sense, detect or jam the signals. This back-and-forth communication interferes with your natural human biofield response. The military currently has a 5G-linked drone swarm for intel collection called OSIRIS, Marine Corps Helicopters Atan-DT, Southern Bell and Bell Labs, per Kaiser, September 2022. When they want to bypass IP protocol, they also have ISIS, or Intermediate System to Intermediate System. The coders writing the apps for Zigbee and Bluetooth have been using K-hop routing based on heat, fenestration of the biofield, and active data collection built on carrier and collision waves. It's open shortest path first. In essence, your body has become part of the computer networking model of open systems connectivity. How? Technically, we the people are now beacon-enabled swatted CSMNCA with collision avoidance. There is also non-beacon-enabled mode called unslotted CSMACA. It's wide-open, off-the-shelf biohacking based on neural networks, your neurons and your biophotons too.
So, what you're looking at here is the dissemination of information on actual control back end of your entire internet worldwide. So when people tell you you're on Web3 and then they tell you you're going to be on some special space, that's not how the internet was built in the first place, so that's not how it works.
We're here with military embedded systems, sensor open system architecture, SOSA, enabling the next generation of flexible and adaptable radar systems. In order to keep up with the continued acceleration of new technology and to be able to protect the warfighter from the latest threats, it is essential that we can turn our deployed platforms into adaptable entities that can evolve over time and are not static. The SOSA, Sensor Open System Architecture, technical standard is the next major step in realizing this goal. As always, I'm going to leave the links in the description for those who want to keep reading. But for now, we're going to go over here. Welcome to DISA, the Defense Information Systems Network, an essential weapon in America's defense. The Defense Information System Agency, DISA, Defense Information Systems Network, DISN, serves all branches of the military services. The executive branch, the combat commands, 14 DoD agencies, and 9 field activities. The DISN is a global enterprise network that enables information superiority and critical communications, said Charles Osborne, DISA's acting infrastructure executive, during the Armed Forces Communications and Electronics Association Defense Cyber Operations Symposium in Baltimore, May 16th. He also said it's the core of the Department of Defense Information Network. Quote, it's a robust, diverse, resilient, and protected communications and computing environment, enabling the warfighter, Osborne said. The scope of the DISN ranges the hotline that connects the White House and the Kremlin to hosting one of Internet's root servers. Osborne said, owning this critical technology means DISA must stay focused on constant evolution. He said he'd like to explore emerging technologies such as the automation of network orchestration. This type of automation is crucial, Osborne said. We need the network to react autonomously before we get a call from our customer as a sensor letting us know there's a problem. DISN's network portfolio contains terrestrial transport, gateways, multinational information sharing, national senior leadership communications, and other special services. The satellite portfolio houses gateway and teleport programs, enhanced mobile satellite services, the unified video dissemination system, airborne intelligence, surveillance, and reconnaissance, digital intermediate frequency, and commercial satellite communications. If we make a comparison, Osborne said, the services we provide would be equivalent to $24 billion in the commercial industry. DISN's portfolio of DoD-owned and leased telecommunications networks, undersea and terrestrial transport, satellites, gateways, multinational coalition information networks, subsystems, and operations support enables the U.S. military and mission partners to leverage, sustain, and exercise distinct advantages over the adversary, support command and control, intelligence, logistics, medical, and other essential missions across the full spectrum of military operations, connect warfighters with each other and their sustaining bases, and integrate and deliver capabilities fluidly across all domains. Not only did Osborne highlight DISN's capabilities and agility, he also addressed the importance of keeping it secure. The DoD is probably the most attacked entity on the internet, Osborne said. We're prioritizing DISN's enhancements and increasing security while we innovate, realizing innovation can't increase network vulnerability. As an example, Osborne talked about the challenges leaders face today, with many users on the DISN browsing social media. It's not just as simple as blocking sites, Osborne said. At DISA, we're looking for ways to separate essential and non-essential browsing, because in today's network environment, many installations have Facebook pages, and even DISA has a YouTube page. The network needs to be agile enough and secure enough to accommodate a wide range of end-user requirements. Osborne said another area of focus is building a survivable network infrastructure. We're increasing capability for mid-Earth orbit satellite transport, transmission security, increasing redundancy and resiliency, and performing an Internet Protocol network redesign for DoD network components in the continental U.S., he said. The infrastructure executive said he is open to discussion on how to leverage DoD assets, commercial knowledge, and academia in an effort to improve the DISN. We can all work together, especially when it comes to showcasing new technology to users used to operating the legacy systems, he said. The DISN is a complex infrastructure encircling the globe and keeping the warfighter connected.
As we see here, the Department of Defense and DISN, all government agencies are a part of it. It's not something that they didn't hear of. They are the ones that have developed it. So all governments are behind the technology that they are deploying on us.
And the Department of Defense literally scans our face when we travel everywhere. So they literally have every single person
in a database
for them to use.
Yeah.
Yeah. I can see why they're working together.
Yeah, it makes sense. It benefits their end goal, as long as that's why we just read it says it's best for us to work together. Yes, because you have the same goal of transhumanism, of humans with no consciousness, and you have remote control for them.
Now let's hop on over here. And here we have PACS database at the DoD. PACS connect to IMESA to validate the identity of individuals and continuously vet their fitness for access to Department of Defense installations. Here you can see security forces use PACS installation access points to scan credentials. IMESA connects PACS with government databases to determine fitness for access. Now let's scroll down. And we're going to stop at this image. Right here we have individuals with acceptable credentials. Individuals with acceptable credentials check in at the installation access control point. The PACS electronically connects to IMESA to vet the individuals for fitness for access. If no derogatory information is found, the purpose for presence on the installation is established. If necessary, the individuals are granted unescorted access to the installation. You can see it says, PACS electronically connect to IMESA. Now I don't know why, but you nerds really like to play stupid. Let's Google IMESA DoD and click on this link. Right here, DoD matching engine for security and analysis, IMESA, access to criminal justice information, and terrorist screening databases. I will leave the link up for those who want to read this. But for now, back to here. And we're going to scroll down to page 19. The Army collects data on AIE technical issues and has developed performance measures and associated goals to assess AIE performance. Specifically, the AIE Reliability Analytics Model tracks real-time information and operational availability with a goal of 100%. The number and age of open help desk tickets with a goal of resolving Tier 2 issues within 48 hours. And field service representative performance with a goal of 100% closure rate for Tier 2 issues.
But they have no idea what they're doing, right? It's only Defense Information Systems Agency who's been running all these back-end systems. Now, keeping that in mind, the Global Information Grid is set up with sensors, which is your Sensors Open System Architecture, Sosa and MOSA. So, basically, to sum it all up, Department of Defense, DoD, has already defined the Global Information Grid GIG architecture with specific feeder grids, kill boxes, smart cities, built in by perturbation of the air molecules around each head, and the biosensors in the biofield.